So we have two more angles that we have to know without our calculator, pi over 6 and pi over 3. And we drew a special triangle for pi over 4. So we're going to also draw a special triangle for pi over 3 and pi over 6. And we can actually do them together. So you have a little bit of space here. So we can have one special triangle for both the 30-degree and the 60-degree. The reason for that, if you draw a right-angle triangle, because that's how we know we can use SOHCAHTOA, and you put one of the angles as 60 degrees, what's the other angle going to be? 30 degrees. So this is going to be part of our special triangle for 30 degrees and 60 degrees. Unfortunately, right now, this triangle isn't special. I mean, it's a right-angle triangle. But you know how last time we made an isosceles triangle? And the isosceles triangle has a special property that two of the sides were the same? This triangle right now has a fancy name. It's called a scalene triangle. And scalene just means that there's nothing fancy about it. So I don't know why it has a fancy name if there's nothing fancy about it, but it's a scalene triangle that doesn't tell us anything. We don't know anything about the sides. They're all different. That's wonderful, but they could be anything right now. So what we're going to do with that triangle is we're going to take the triangle, copy it, and flip it over. Because if I copy it and flip it over and draw it again on the other side, it makes sense that this would be still 90. If I flip it over, this would be 60. Oh, I should do. Don't have to flip the 60. And this would be 30. And putting those two triangles together, we get a special triangle. The green one and the blue one together, what kind of triangle is that? Equilateral. And what do you know about an equilateral triangle? All sides are the same and all angles are going to be 60. So again, just like last time, you can choose any number you want to be for all three of the sides of this big equilateral triangle. You could pick 37 like I think 37 was the number we said we could choose yesterday. But to be easier, we're going to choose 2. The reason we're going to choose 2 because you can see the bottom side gets split in half. And 1 plus 1 is 2. So if all the sides were 2 of that big triangle, then you would have the bottom split into 1 and 1. And now that you have two sides of a right-angle triangle, if we look at the blue one, we can do a squared plus b squared equals c squared. And if you did that, you would find out that this other side is the square root of 3. So what that means is we can now figure out what sine of 30 is, cos of 30, and tan of 30 just by looking at the ratios. We can also do sine of 60, cos of 60, and tan of 60 by just looking at the triangles. So looking at the triangle, we see 30 degrees, sine is opposite over hypotenuse, 1 over 2. And if you went to your calculator and typed sine of 30 degrees in, it would tell you 0.5. If you had your calculator in radians and you did sine of pi over 6, it would tell you 0.5. If we look at cos of 30 adjacent over hypotenuse, you're going to get the square root of 3 over 2. Tan of 30, opposite over adjacent. You'll get 1 over root 3. Again, we will rationalize the denominator and write it as root 3 over 3. And similarly, you could do the same thing for sine of 60, get root 3 over 2. cos of 60, 1 over root 2, and tan of 60 would be root 3 over 1, which we'll just write as root 3. So this special triangle will allow us to fill in everything on the next two parts of the circle. Can I scroll up? Not quite? Okay. So the first one we're doing here at the top of the page is the pi over 6 or 30-degree family. Here are those points on the unit circle. We'll start with degrees. If we're doing the 30-degree family, the way the families are connected, that means every angle in this family has a reference angle of 30 degrees. So the question is, what is this angle if it has a reference angle of 30 degrees? 150. And what would this angle be if it had a reference angle? 210. And finally, the one in quadrant 4 would be 330. In radians, this is the pi over 6 family. Okay? A key thing that's going to help you with all family members, pi over 4, pi over 6, and pi over 3, in dealing with radians, is to know that here, this is pi, and all the way around once would be 2 pi. Okay? And just like in degrees, you went 180 minus 30 to find the 150. You're going to have to do pi minus pi over 6 to find the 1 in quadrant 2, and pi plus pi over 6 to find the 1 in quadrant 3. And what's really going to help you is to think of pi for the pi over 6 family as 6 pi over 6. Does that make sense that 6 pi over 6 is the same as pi? And 12 pi over 6 is the same as 2 pi. If you do that, and you have 6 pi over 6's and you subtract pi over 6, you will get 5 pi over 6. And you'll notice that all the ones in quadrant 2 are always 1 less than the denominator for that reason. If we go into quadrant 3, you'll notice that they're all 1 more than the denominator for that reason. Because you would have 6 pi over 6, and then you'd add another pi over 6, which would get you to 7 pi over 6. And in quadrant 4, they're going to be 1 less than double the bottom, because double the bottom is all the way around. And then you subtract 1 pi over 6. That's going to be a strategy to help you memorize this, because you're going to use that when you do the quiz on this material. Now we go to our points. Remember, points on the unit circle, big idea, are cos and sine, or sine and cos? Which one's which? Cos is the x-coordinate, sine is the y-coordinate. So you just go to cos, and you look at your special triangle, and we found out that cos was root 3 over 2, and sine was 1 over 2 for 30 degrees. Then all the points are going to be the same. The only difference is some will be negative and some will be positive according to the cast rule, or just thinking about in that quadrant. If I go to quadrant 2, does it make sense that my x-coordinate is going to be negative, but my y-coordinate is still positive? And when I go to quadrant 3, both of those coordinates are going to be negative. And when I go to quadrant 4, my x-coordinate is positive, but my y-coordinate is negative. And finally tan, and again I'll write it with the radians. Tan of pi over 6, when we rationalize the denominator, was root 3 over 3. So now all the tans are going to be the same. The only difference is based on the cast rule. Quadrant 2 is going to be negative. Quadrant 3 is positive again. And quadrant 4 is negative. Six, because I'm just doing the radians. These are all pi over 6 families. So again, like we saw yesterday with the pi over 4 family, it's really easy to see something belongs to the pi over 6 family because when that fraction is reduced, all the green ones are pi over 6. 5 pi over 6. Pi over 6, 7 pi over 6, 11 pi over 6. Okay? 3 pi over 6 is not part of the pi over 6 family because you could reduce it to pi over 2 and then you'd say, oh, that's part of the axes family that we saw yesterday. But if you had 117 pi over 6, no, that's a bad one. 119 pi over 6. 119 can't be divided by 2. It can't be divided by 3. Can't be divided by 6. That's already reduced. We would know that that belongs to the pi over 6 family. You would have to figure out what quadrant it belongs to. Okay? That'll be a skill that we're going to develop, and you're going to find out that that belongs in quadrant 4. And if it belongs in quadrant 4, then you can figure things out about it. Like sine of 119 pi over 6. If you type that into your calculator, I can tell you right now your calculator is going to tell you negative 0.5. Okay? So, who was the last person to answer a question yesterday? Okay, Hiroki gets to pick someone for today. They're going to figure out cos of pi over 6. Jesus. Cos of pi over 6. Square root of 3 over 2. Remember, cos is the x-coordinate. Okay, Jesus, pick someone for sine of 150 degrees. Albert? Talbot. Okay, what question did I ask? Sine 150, yes, is 1/2. Good. All right, Talbot, pick someone to do, let's do cos of negative 150 degrees. Harrison. Root 3 over 2. Okay, negative 150 is going to go backwards, so it's going to end here. And it's going to be negative root 3 over 2. Harrison, pick someone to do negative, let's do tan of negative 7 pi over 6. Tan of negative 7 pi over 6. Tan of negative 7 pi over 6. Okay, good. And then which quadrant is it going to end in? Close. It's going to end in 2. And this is the way I'd like you to think of it. Okay, here we've got, this is 7 pi over 6, right? So when I'm going negative, I have to kind of go into the third quadrant. Negative-wise would go like this. It would end in quadrant 2. So tan of negative 7 pi over 6 will be the same as tan of 5 pi over 6. Yeah. Okay. Pi over 6 family is done. Now we do the pi over 3 family. Again, we can start with degrees, because this is our 60-degree family. We'll have 60 there. Same reference angle. Quadrant 2 would be 120 degrees. Same reference angle, quadrant 3, 240. And same reference angle, quadrant 4, 300. Again, same idea we used last time. We think this is pi, this is 2 pi. If you wrote pi over 3, you'd have to have 3 pi over 3 to be equal to pi. And 2 pi is the same as 6 pi over 3. So we notice the same thing happens in quadrant 2, that the angle is just 1 less than the denominator, because you would take 3 pi over 3 and subtract pi over 3. And here it will be 4 pi over 3, because you just add 1. And then finally, subtracting 1 from double, you would get 5 pi over 3. Our coordinates, looking at our special triangle, now cos of 60 is 1/2, and sine of 60 is root 3 over 2. Same thing happens in the other quadrants. The values are going to be the same. You just have to figure out, oh, here the x-coordinate is negative, the y-coordinate is still positive. Here both the x and the y-coordinate are negative. And finally, the x-coordinate is negative and the y-coordinate, x-coordinate is positive and the y-coordinate is negative in quadrant 4. Tan of pi over 3 is root 3. So now you just have the same values, but use your cast rule. Zach was the last one, so Zach, pick someone to say what cos of 2 pi over 3 is. Cos of 2 pi over 3. Negative 1 over 2. Sine of 5 pi over 3. Kevin, pick someone. Eric. Sine of 5 pi over 3. Negative root 3 over 2. Excellent. Pick someone for tan of 240. Justine. Root 3. Pick someone for tan of negative 60. Negative root 3, because negative 60 would be the same as 300, right? And one more, let's do tan of negative 5 pi over 3. Amy, pick someone. Lane.
Can I hear the question again?
Yeah, tan of negative 5 pi over 3. Root 3, because negative 5 pi over 3 would go all the way around and end in quadrant 1, and it would be positive. Good job. Is everybody done? Yes.
The bottom left, is that negative root 3?
That's positive, because that's in quadrant 3, and tan is always positive in quadrant 3. Yes?
Can you go back to this special triangle stuff for a second?
Special triangles for a bit? You bet.